Hi, welcome back. Now that you've had a chance to watch that video that was professionally done and very clear, we're ready to answer these questions. These guided notes are exactly like the next slide where I'm going to ask you to do this on your own. So if you think you got it, you can skip this slide and you can skip watching this video. But let me just lay out the idea that last video explained. Let's take a minute to look at a bag that contains 4 red marbles, 5 green marbles, and 6 blue marbles. Step 1. Well, we know that probability has to do with a fraction, and the denominator of the fraction is the total possible choices. So step 1 is to find the total of all the marbles. 4 plus 5 plus 6 is 15. That'll be the denominator of our first probability problem, calculating the chances of a red marble. So I'm going to take and find the probability of a red marble. The denominator is going to be 15, and the numerator is the total number of marbles in the bag. 4/15 is the answer to the first one. Now remember, we can express probability as a fraction or a decimal. We can also change this to the decimal, and we agreed to round to 3 places. 2, 6, 7. That's the probability, the chances of drawing a red marble. Let's do the same for green. The denominator is again 15, and the numerator is the total number of green marbles, 5. Let's turn this to a 3-place decimal number. We have the probability of drawing a green marble. Let's look at the next one, a red or a green marble. So if we want a red or a green marble, I'll put the answer in purple. If I put my hand in the bag and draw a red marble, I win. If I put my hand in the bag and draw a green marble, I win. The denominator is still the total number of marbles, but now I have 2 choices, red or green. The numerator is 9, and if we turn that into a 3-place decimal, we get 0.600. All right, now we're ready to do that replacement theory. Let's look at the first one. We want a red marble and then a green marble. So the first thing we're going to do is find the probability of drawing a red marble. We just did that a minute ago, 0.267. When we put our hand in the bag, there's 15 marbles, and when we pull a red one out, we have a 0.267 chance, a 26.7% chance of drawing a red marble. Now, when it says replacement, what that means is we put that red marble back in the bag, so there's 15 again, and now we want to find a green marble. There's the chances of drawing a green marble. When we multiply those two together, we'll get the probability of putting our hand in the bag to get a red marble, returning the marble, and then pulling out a green marble. If you think about it, it's not very likely because there's so many marbles in the bag, and when we multiply these two together, we get 0.089. That's about a 9% chance that you would do that. Here's the next thing we want to look at. Without replacement. So we're going to have 2 fractions multiplied together. The first fraction is pulling a red marble out. So here's the chances of pulling a red marble out. There are 4 marbles in a bag of 15. But without replacing, when it's time to draw out the green marble, something different happens. There are still 5 green marbles in the bag, but now instead of having 15 to choose from, there are only 14 that remain. When we multiply those two together, we can multiply them as fractions, or we can multiply them as decimals. Either way, we're going to get the answer 0.095. That's a 9.5% chance of doing it. Here's the key idea. With replacement means there's more marbles in the bag, So our chances are lower that we would complete our mission. Without replacement gives us that slight edge. That second drawing of a green marble is a little bit easier. That's why the probability that will happen is a little bit higher. Now let's take a look at something that should seem very unlikely to you. So the answer won't be 9% or 9.5%. I hope you're expecting an answer that's a little bit smaller. Let's look at the next one. A red marble first. The chances of drawing a red marble is 4 out of 15. And a green marble, the chances of drawing a green marble is 5 out of 15. And then a blue marble. The chances of drawing a blue marble, I don't think we did that one yet. There's 6 total blue choices out of 15. When we multiply these three numbers together, we'll have the probability of pulling a marble out, putting it back in, pulling it out, and putting back in, and pulling it out, and putting it back in. When you do the math, you find out that the answer is 0.036. Yes, there's a 3.6% chance that that actually would happen. Now, it's a big important thing to me that you understand quantitative, and if you realize, without doing the math, that doing this exact same thing again, pulling a red marble, a green marble, and a blue marble, but not putting the marble back in the bag, will be a little bit easier. So you'll get a number a little bit bigger than 3.6%. You've grasped the concept. That's fabulous. Let's look at how that works out. If we want to draw a red marble, there's 15 marbles in the bag, and we have 4 chances to draw a red one. That's the probability of drawing a red one. Now, we keep that marble out, and we draw a green one. This time the denominator isn't 15, there's only 14. There's still 5 green marbles that we can pick, but there's only 14 marbles we have to choose from. When we get to the blue, there's still only 6 marbles that would be a blue marble that we could pull out. But now, there are only 13 marbles in the bag. Let's multiply this together and see what we get. We multiply those 3 numbers together, we get 0.044. Hey, look at that, 4.4%. There's a higher probability that if you don't put the marbles back in the bag, you'll accomplish your mission than if you do put the marbles back in the bag. So, let's take a look at this last one. What are the chances we would draw a red marble, and then another red marble, and then another red marble, without putting them back in the bag? Think about that. Our bag contains a total of 4 red marbles. This is not going to be an easy task. Let's find the chances that we can do this. Before we do, I want you to guess. Remember, probability goes from 0, meaning there's absolutely no chance anyone could ever do that, to 1, which means there's a 100% chance anybody could do that anytime they tried. This problem lies somewhere in there, and I hope when you look at it, a red, then a red, then a red, that this is going to be a difficult task. Let's do the math. There are originally 15 marbles in the bag, and there are 4 marbles, so when I put my hand in the first time, I'll have a chance of I'll have 4 chances of drawing a red marble out. Now it says without replacement, so once I grab that red marble, I'm keeping it out of the bag, and I'm going to try it again. This time there's only 14 marbles in the bag. Let's think about the numerator again. If you thought I was going to write 4, you forgot that I was so happy I picked a red marble the first time that I set it aside. Only 3 marbles remain. I hope I did it the first time, and the second time I hope I do it the third time. Now, 13 marbles remain in the bag. There are only 2 marbles left. I have a 2 in 13 chance of getting that marble. Let's put this in our calculator and multiply these 3 together. 0.0087999. That's a decimal answer. That's the probability, the chances that I'll do it, that I'll accomplish the task of drawing 3 red marbles in a row. Remember we talked about decimal probability. That's a great thing to calculate with, but if we turn it into a percent, that'll make it really easy to understand. Let's recall on how to turn something from a decimal into a percent. We move the decimal 2 places. So when I look at this number, the answer that I get for drawing 3 red marbles in a row is nothing goes there, nothing goes there. It's such a small number, it's 0.9%. Do you see how the 8 and the 7 interacted to get a 0.9%? 0.9 is close enough to 1% that we can say under 1%. Let's think about that for a minute. We had a bag, and there were 15 marbles in it. We tried to draw a red, a red, a red, and the chances of that is 1%. If you're the kind of person who plays cards, think about having a deck of not 15 cards but 52 cards, and you try to draw an ace, an ace, and an ace. That's why that almost never happens. The chances are much lower than 1%. If you're curious about it, you could calculate the odds of drawing 3 aces in a row from a deck of 52 cards. I hope you've enjoyed this. I think you're ready to do the guided notes. Give it a try.